point where the tangent line is horizontal. Find the coordinates of the point along the curve defined by y is equal to x squared minus 2x minus 3, where the tangent line is horizontal. So this is a parabola. This curve or this function defines a parabola. And if the parabola is available, if we can see the graph right away, by simple inspection, we can tell that the tangent line to the curve is horizontal at the point A, whose coordinates are 1 and negative 4. The tangent line is going to be horizontal when x is equal to 1. Now, let us verify that. Without relying on the graph, let us verify that that is indeed true. So this is what we shall do. We know that the tangent line to the curve and the slope of that tangent line will give us the derivative of the function. And in particular, we will look for where in the curve is the tangent line going to be horizontal. And when it is horizontal, we know that the slope of that tangent line is equal to 0. So in effect, what we shall do here is we shall find for the value of x where f prime of x is equal to 0. So we will first get f prime of x. So using your theorems, our rules to get the derivative of functions, so this is just equal to 2 times x raised to 1. You bring down 2, you multiply it to x, and then you subtract 1. And then minus 2, because that is the derivative of 2 times x, or negative 2 times x. It's just minus 2. So this is your derivative of your function in general. That is the function that defines your derivative. We will equate it to 0. And so, where or when is this equal to 0? It is equal to 0 when x is equal to 1. And so that's it. We already got it. Our tangent line to the function is horizontal when x is equal to 1. And when x is equal to 1, we must look for the y coordinate, because the instruction here is find the coordinates of the point. And so when x is equal to 1, y is equal to f of 1. And f of 1 is equal to this. Where did this come from? It came from this. 1 squared minus 2 times 1 minus 3 is equal to negative 4. And so the tangent line to the curve is horizontal at the point with coordinates 1 and negative 4. Use derivatives to find the values of x where the tangent line to the curve y is equal to negative x cubed minus 2 times x squared plus x minus 1 is horizontal. Now this time, I am not going to show you the graph. We will get the values of x where the tangent line to the curve is horizontal using derivatives. So we know that the slope of the tangent line to your curve is horizontal when the slope of the tangent line is equal to 0. And the slope of the tangent line gives the derivative of your function. And so what we shall do is we will get f prime of x and then we will equate it to 0. Again, where did this come from? F prime of x is equal to negative 3x squared minus 4 times x plus 1. It came from this. So applying your rules for getting the derivative, you will keep the negative sign, minus, and then 3, you will bring it down. So it's going to be negative 3 times x and then minus 1. Minus 1. And so that's it. Negative 3x squared. Minus, again, 2, you bring it down. So it becomes 2 times 2, and then you subtract 1 from the exponent. Negative 4x. And then the derivative of this with respect to x is just 1. The derivative of a constant function is 0. So we will equate the derivative to 0. When is this equal to 0? Where is this equal to 0? Solve for x. You can do this by factoring. You can do this by quadratic formula. But in this video, I will do it through completing the square. You know, most students dread the technique of completing the square. But I find it to be helpful, okay? So completing the square is like one of your tools in your Swiss knife. You better keep this. So let us solve this by completing the square. We begin by making the coefficient of the leading term equal to 1. And we can do that by dividing by -3. Okay? Dividing by -3. Okay, you will divide all of this by -3 is the same as multiplying by -1/3. Okay? So that is just the distributive property of multiplication over addition. So -4, look at this, -4 times -1/3 is positive 4/3. -1/3 times 1 is -1/3. And then, of course, -1/3 times 0 is just 0. Okay, so transposition, x squared plus 4/3 times x is equal to 1/3. And then, you know what to do next. You will divide by 2 the coefficient of x. And 4/3 divided by 2, 4/3 divided by 2 is just the same as times 1/2, okay? So look at that. So it becomes 2/3. And then what will you do with that? You will square it and you will add it to your terms. So x squared plus 4/3 times x plus the square of 2/3 is equal to 1/3. Of course, you will also add the square of 2/3. And the square of 2/3 is just equal to this. It's equal to 4/9. Now, take a look at that. Okay? Take a look at that. So, you can now see the reason why I did not simplify this right away, because I want to see that 2/3 there. I'm going to use it. It's going to be the constant term in my binomial. So this one now is the square. This one is the square of a binomial, and it's equal to this, 7/9. Now, I have the feeling that some of you are kind of lost when it comes to adding fractions. Well, what I do here is I write 1/3 as 3/9. 1/3 is just 3/9. And now that they have the same denominators, 9 and 9, so it's equal to 7/9. So we should get the square root. X is equal to plus or minus the square root of 7/9. Okay, it came from this. Minus 2/3. So we have two values for x here. One is negative square root of 7/3 minus 2/3, and the other is positive square root of 7/3 minus 2/3. At these values of x, the line that is tangent to our function is going to be horizontal. This is our graph. The graph of f of x is equal to negative x cubed minus 2 times x squared plus x minus 1. And we are looking for the values of x where your tangent line to the curve is horizontal. And we know that when the tangent line to the curve is horizontal, its slope is equal to 0. So in order to get the values of x where that is going to be true, what we shall do is we will get the derivative of your function, equate it to 0, and solve the equation. We found out that the values of your x are x sub 1 is equal to negative 1.55 and x sub 2 is equal to 0.22. So these are approximations, okay? So we rounded off our values of x to the nearest hundredths digit.